The broadcast is now starting. All attendees are in listen-only mode.
Good morning, all. Good morning, sir. How are you?
Thank you. Today's a Thursday, right? Programming.
Today is
That's a
data
different
analysis.
to this programming. Okay. So
That's right.
it's all set, I guess.
Yes, I think so. How was your weekend, sir?
It is
Good.
mowing lawn. Hopefully it doesn't grows too much on me.
Man. Yes, it's wonderful to have grass. But my son, my nearly 2-year-old, has decided this last in the spring, he was deathly afraid of lawnmowers.
Right.
Yes, did not want to be around it.
Buy him one of those toy ones.
He ended up doing that, but that was only after he became more comfortable.
Oh.
And so I was picking him up and mowing, and there's like some heavy tools. It's wonderful, but it's just hilarious at how mowing you should take like 2 hours for the whole round. 3 acres or 3.
That's a big.
I relatively speaking, but that's because we're right. So
I'm hoping with half an acre land. That's too much. Keep it green. Winterize. When are you going to winterize it?
Yeah.
Maybe.
At some point. Yes. I need to get some more like winter fertilizer.
Okay. I'll talk to you later.
All right. Thanks, sir. Good morning. How are you all? Hi, how's your last week, Mark? Yep, Mark, how are you? TBI? Oh, cool. Another guy from the TBI, saw the email. Excellent. Is it, I mean, I went into CIT and I had to go for individual classes, and I did. And then some I got restricted, and I was webinar, some I didn't. That's right. So, kind of a mishmash. Most I got in, I think I like 2/3 of my got in. So that was, yeah. I'm waiting, the last people didn't come, so I'm here, but yeah. Cool. Thanks for putting them on. good morning, everybody. While we give everybody a few more minutes to arrive, this should be kind of old hat to you by now, perhaps not, but the materials are just up on my GitHub website. And so if you will go to, what is it, the URL in step number 2, right? And then at this point, just download the entire repository using that wonderful big green button. If you're doing it on the lab machines, right, there are, or if you're following along right through the series, then you will probably have multiple versions of that installed. And so I would say pick the latest one with the, say, the largest integer at the bottom, or I mean at the end, and then just move that to your desktop. And there should be a folder, was it 05 with Python data analysis in it. And then we're assuming, right, that you have installed the Anaconda distribution, right, and you have the Python programming language and right, the software, especially pandas, installed already, but we can look at that very quickly this morning. Okay, give me just a minute. And then in the URL, notice that that's right an underscore between biologist and not a dash. That may be causing problems. If you're having problems getting to the GitHub page, then try just going to my GitHub page, and then from there should be the pinned repository. Is anybody in the lab or in the class not able to download those materials. Those are all the defaults. Okay. So I'm going to go ahead and get started. So if you are, if you're with us, if you will take a look at the link here, this is where you can download the materials from. If you're online, I think there's an installation document that has the URL. Right, so it's just a GitHub page with my username, Burke Squires is one word. So good morning, everybody. I see at least one or two fresh new faces, so I'm going to go through my wonderful spiel yet again. Right? Come on in. My name is Burke Squires. I'm with the National Institutes of Allergy and Infectious Diseases, Bioinformatics and Computational Biosciences branch, the BCBB, and we are what I like to call a collaborative core within the BCBB or within NIAID, and so we develop certain bioinformatics tools, right, and projects for people to use, and I'll show you a couple of those in a minute. But then we also do, say, collaborative consulting, right, with predominantly intramural NIAID researchers. But we also have at the very bottom, I think, of the last Python notebook, Jupyter notebook we're going to be looking at today. There's my email address, and then there is this Science Apps email address that if you have questions, right, we will do the best we can to answer them. There is the group is made up of about a third computational biologists, about a third bioinformatics software developers, and about a third program managers. And so there is a lot of expertise in the group itself, right, which if you email scienceapps@niaid.nih.gov, right, you can get access to. Good morning. For those of you who may not be aware yet, this is our new bioinformatics NIAID portal. So this is at bioinformatics.niaid.nih.gov. And the reason I draw your attention to this is that you'll see here, right, there is the information on, say, today's webinar. But if you go under training resources here, there will also be the links to, say, the previous webinars or the previous seminars that we've given. And I am, I think, a seminar behind as far as updating it with a particular link, right, the YouTube link. So if you have any questions, please don't hesitate to email me. But I would say, let's start here if you're looking for past materials, past seminars. In addition, there are lots of other seminar materials, right, from previous seminars that my group has given, right? So I would invite you to take a look. And as always, right, if you have suggestions, criticisms, or comments, right, with regards to, say, the seminar series here, with regards to the website or anything, please let me know. Okay? I want to draw your attention to a couple of websites. If you're doing microbiome research, or if you know of anybody doing microbiome research, one of our current projects is this NIAID. It's a microbiome analysis portal. It is based on, say, Amazon Web Services. And so for those who find it challenging, right, to do microbiome analysis, you can go onto the portal here, you can upload your data, right, do an analysis and not have to install anything, right, on your computer, right, and then get some wonderful reports. There's a great amount of visualization. And so it's a fantastic resource, right, if you're doing microbiome research. And then we are also one of the founding members of this NIH 3D Print Exchange. And this is a great place or a great resource if you're looking to get, obviously, a 3D model of something, right, either a molecule, but something kind of outside the normal or outside the boxes. You can also find a number of, say, lab pieces of equipment out there that can be 3D printed. So if you're looking for something that is a little bit out of the ordinary, or you just want something that works, right, for your particular situation, right, this is a great place to go and find some resources. We're just going to go for a moment to GitHub and to the Python and Biologist. Okay. And as you'll see, today we're going to be talking about data analysis with Python, specifically with this pandas package. Right? This is part of a series of Python seminars. Right? They are being archived, as I mentioned, on the NIAID Bioinformatics portal. If you have signed up for the webinar, then you should be getting an email or a notice each time a seminar happens, right? And so I would invite you to sign up, or if you would rather either not sit in the class, or if it's more convenient to, say, take it at your desk, right? Of course, you are welcome here. I'd love to see your wonderful face. But the information on signing up for the GoToWebinar is here, as well as the series dates and times, okay? And so today, we're going to be talking about data analysis with Python and pandas. And this particular seminar, right, focuses on the pandas package. And I would say, in large part, this pandas package is a primary reason, if not the primary reason, for Python being so incredibly popular in, right, the field of data science. As we'll see, the NumPy package underlies all that pandas does, and so without it, pandas would be, in essence, crippled. But what we see is that, right, there is, right, building on the shoulders of giants. So we as scientists, right, are familiar with that, right? We work on research that others have done, and we extend it, and so something similar happens, right, in the open source world of programming. And so what I want to do today is, we're going to look at two different packages. We're going to look very, very briefly at this NumPy package. And in large part, that is just to give you an idea of what capability, right, it provides for you. But then I'm going to essentially say, ignore that. And then I'm going to say, focus on pandas, right? And so if we have done all this correctly, right, we're going to come down here and you should see something like this, although a little larger, okay? You will not have some of these files here at the bottom. That's because I have previously run, right, this notebook. So if you have, right, downloaded the files, unzipped them, and copied them to your desktop, then you should see something similar to this. You should see a 05_python_data_analysis folder. And in there should be a data subfolder. There should be a number 1, right, IPython notebook called YNumPy. And then there should be a number 2 called an Intro to Data Analysis with Python, right? Is anybody not able to get here? Excellent. Okay. So, right, remember we're using the Jupyter notebooks, right, in large part because they're fantastic for doing our work, but I would say they're even better, I think, right, for training purposes and for walking through the material here in the class. So please don't hesitate to let me know if you have any questions, right, or suggestions or criticisms. So then I want to jump into this YNumPy. And see, I think I have it on another slide. I will see if I can find it later. But there is this fantastic graphic that an astronomer, Jake Van de Plas, who is a big person in the Python world, put together, which he called the Python scientific stack. Okay? And let's see here. And so I think this may be a couple of years old, but in large part, many of the components here have not changed. Okay? And so what we see here is that obviously, right, we're focusing on Python, right? That is the core of what we're learning. But right above that, in this first layer of this Python scientific stack, are some of the components that we are becoming, right, very familiar with. Right? We've been using this IPython, right? That is another Python interpreter that we've been using, and that is what is behind, right, this Jupyter project. Okay, so we don't necessarily see IPython as much, except that, right, all the Python, the file extensions that we're using, right, are IPYNB. Right? That's short for, right, IPython notebook. Okay? What we're going to look at very briefly today is this NumPy. Okay. And so this underlies a great amount of data analysis, right? And then there is also this other component, Python, that allows you to, right, convert or to utilize kind of C-based structures, right, in your Python programming. So that's a little bit above what we're talking about in this course. But what we're going to be focusing on today is briefly a little bit of NumPy, and we're going to be spending most of our time in pandas. And then we'll see a little bit about how matplotlib, right, is the primary plotting library in Python, and how that works very closely with NumPy and pandas. And then we will cover that, right, in greater length in our data visualization seminar. So, right, you all can read this information very easily. Okay, what I want to draw your attention to is, as I mentioned, I think in the introduction to programming, right, Python itself is a scripting language, right? We program it or we script it, okay? But in large part, it is different from something like C++ or Java because the code is not compiled, right? Compiled means that you create a binary of it that doesn't change when it runs, right? And so you want something like that when you're using, say, Microsoft Word or your browser. You want it to operate as absolutely fast as possible. Okay? From the Python perspective, I've said before that in my opinion, I don't really care if my program is 5% faster, right? In large part. Okay? I would much rather benefit from the fact that it takes me 5 or 10 times less amount of time to put it together, right? So I can create it much faster, but the trade-off is that there's, right, some slowness at the very end, okay? But that, right, we can overcome as if you analyze your code and you use something like Python, right, you can overcome those limitations. But for the most part, right, we don't necessarily bump into those limitations all that often. Right, what we're interested in doing is coming up with a Python program or script, right, that does our analysis and allows us to continue our work. But the fact that Python is not inherently meant for speed doesn't mean that when we are using it, it is not incredibly fast. Right? What we want to look at with regards to NumPy is that the core of NumPy, right, is actually been written in C. That means it takes advantage of all of the wonderful capability and speed that's available, and then we don't ever see those portions. Right? All we see is a package, right, that looks like it's mainly written in Python, okay? And everything that we work in is Python based, and so that is a layer that we don't necessarily see. So in a very, very simplistic example, let's say for a moment, right, we're talking about, say, two-dimensional arrays or matrices, and we want to do some manipulation, right, with three different matrices. Right? In this case, A, B, and C. And so we want to do something like right, multiplying the matrix of B times C, and we want to add, right, that two-dimensional matrix A to it. And we want to save that into a particular result, Z, excuse me. In, right, pure or traditional Python, right, this is one way that I would do it. I would create three different arrays. What we're doing here is we are creating three essentially lists of integers, right, that are 1 million integers long. Okay? We use this function called range, and what that does is just starts at 0, right, because Python is a 0-based language, and then it counts all the way up to, right, 1 million minus 1. Okay? So if I click on, or if I run that, okay, then what I see is actually, what I've done here is I was allowing you some space to, right, retype it if you're interested. Okay, but there's no reason necessarily to have the two of those in there if you don't want. Okay. And then what I'm doing down here is I have my code, which is, right, these three particular lines. Okay. So what I'm doing here is for Z equals, right, open and close the square brackets, I'm saying I want to create an empty list or an empty array. And then for each of my, right, 1 million different entities or right, elements in my list, I'm going through and I'm multiplying and I'm adding and I'm saving that, right, to my new array or my new list, right, which is what we call it in Python. Okay. So in between the pound signs right here is the actual code that we're using. Okay. The rest of this is code that enables us to see how quickly this code runs. So here when I say import time, and I'm clicking on, or I set up start time, and I set up, right, another time here, and if I run this, what I see that is that it takes the computer, right, it takes my laptop about 3/4 of a second to do that operation. Okay. First of all, that's much, much, much faster than I could do it, right, by hand. So, right, we're already off to a great start. But if I do the same thing, right, in Python, right, a few different things have to happen. The first thing is that this is one of the first cases where we've seen where, right, we are not using something that's part of the Python standard library, right? This is a separate package written by separate developers, but that's thankfully, right, open source and available for us to use at no cost. But because of that, right, two things have to happen. First of all, I must install it on my computer. That, you'll notice, right, I haven't asked you to do that. Okay? What we did was when we installed the Anaconda package, right, that is installed as part of it, right? The NumPy package is installed as part of that Anaconda distribution, okay? In addition to the pandas package, right, that we're going to use as well, okay? That type of installation, right, has to happen only one time. But every time I want to use that package, I must import it, or I must link to it, right, from my current program so that the Python software, right, knows how to access it. So we have done the installation already, right? On occasion, I'm going to update that, but that's not right, absolutely critical. Okay? But here we see that I am importing NumPy, and then because right, we're all wonderful but lazy programmers, we're going to give it an abbreviation, right, that makes it easier for us to utilize it from this point on. Okay? I can come along and say, right, just import NumPy. Right? That works great. But if I say import NumPy as NP and I run this, then what that allows me to do is that instead of using the whole word, I know 5 whole letters, right, NumPy in my line, I can now use the abbreviation NP. Okay? And I would say, I think that's right. It makes, it's not necessarily good programming practice. It's a nicety, right? You don't have to do it by any means, but you also don't want your lines of code to run incredibly long, right? And that gets back at that whole idea of readability, right? So if I have a bunch of lines that are very, very long, then when I go through or somebody else goes through to read my program, right, they're going to be constantly scrolling back and forth, right, and then up and down, and it's going to make it more difficult to read. Okay? So this abbreviation, while in large part a nicety, also helps contribute to that readability. Okay. So I have imported my NumPy, and now what that does is that gives me right availability that I didn't have beforehand in pure Python. Right. We saw above where I was using range. Here within NumPy, there is a function that does the exact same thing. Right. It creates a list or an array of numbers. In this particular case, it's called a range. So I type in my A, B, and C, right? I type in NP, that's my NumPy. So I'm saying from NumPy, I want to utilize this A range functionality. If we look for a moment, and I do my dot notation. What that means is I want to access something within NumPy. I hit the dot, and then if I hit the tab, this allows me to see some of the functionality that's available within the NumPy package. Okay? And so I am going to just simply scroll very quickly through here, but you can see that there is an immense amount of capability here. Okay? If I start typing a range, okay, then I get there, and then I want to do the same thing, and I want to compute the first million integers, starting once again at 0. So I run this square, I run that cell, and then very quickly I have my 3 different lists or my 3 different arrays. And then I want to draw a few things to your attention. Right? We're going to do the exact same thing where we're going to run some Python code, and then we're going to time it to get some idea of how long that takes. Okay? But how many lines did this rather simplistic function, how many lines did it take in pure Python? Right? 1, 2, and 3. Okay? In NumPy, what we're doing is we see something that is much, much closer to actually the algebra, that we would have seen in school, and it very closely, basically it exactly matches what we're wishing to do, We want to multiply, our lists, B times C. We want to add that to my list A and then save it, in a new list or a new range, a new array, in Z. So the first thing we see within NumPy itself, this is a NumPy capability, is that I can start typing out my mathematical operations, but I can do it in a way that much more closely, say, mirrors the mathematics. Okay? And so if I run this, and I have yet to find a way to do this without cutting and pasting here, but I'm going to come down into results, and I'm going to cut and paste this is the time it took to compute it using regular Python. This is the time it took to compute it using NumPy. And then if I run that, it actually seems like they've done some more work and they've tweaked it even more, okay? So at this point, doing that single operation in NumPy is now, right, about 82 or 83 times faster, right? That is incredible, okay? So when people, right, if somebody comes up and tells you that, you know, that's great that you know how to use Python, but Python is so slow, right? That is not the case, right? If you're writing in pure Python, that may be the case, but I can very quickly write in pure Python, and then when I need to, if I use the NumPy package, right, or as we'll see in a few minutes, the pandas package, right, then I can take advantage of all of this and still write my software very quickly. Okay? So, in addition to being much, much faster, right, what the NumPy usage allows us as well is to be more memory efficient. And so the storing of the 3, say, million integers in Python itself takes just under 100 megabytes of data. Okay? On the computers that we have with, say, 4 or 8 gigs of RAM, that is not going to kill us by any means. But if we think about the fact that doing the exact same operation uses about 1/3 in NumPy, then we are seeing a dramatic, right, speed up, and then we're using 1/3 less RAM. I'm sorry, 2/3, right, less RAM. Okay? The advantage there is that if you are doing, right, work on much, much larger, right, types of data structures, then right, Python or NumPy can handle it. Okay? And then down here as well, we'll see very quickly that if I run this cell, right, what is also something that we talked very briefly about when we talked about, say, the advantages of Python, and I spoke about community. What is incredibly nice between, say, the packages of NumPy, the developers, excuse me, of NumPy, the developers of pandas, and say the developers of the matplotlib package, is that they all work closely together. And so I then can come along and in a few lines of code, right, I can import my plotting library, right? This is, remember, using this line magic within the Jupyter Notebook. Pylab is just a sub-component, right, of the matplotlib library. I can import the NumPy package. Do I need to import the NumPy package at this point in time? No, I do not. Okay, I do not. The reason I draw that to your attention is that it's already, right, run in my notebook, and so I don't have to do that. The reason that I put it in here is that it makes cutting and pasting this piece of code, right, much easier if you want to go and reuse that. Okay, but this is not necessary to run it at this point. And so I'm opening NumPy, I'm telling that I want to create a plot, right? I'm creating some data, right? I'm using a cosine function, right, to calculate some y values, and I plot that. Okay? But I don't have to, right? I don't have to reformat anything, right? The plotting function automatically understands that I'm using a NumPy package, right? And it takes advantage of that. Okay? So the takeaway is that NumPy, right, is incredibly fast, okay? But if you look down here, part of the challenge, right, of NumPy is that everything in a NumPy array must be homogeneous. Okay, that means everything must be an integer if you're using integers, or a string if you're using a string. And very often, right, in biological data, that's not the case, right? I'm going to have a gene name as a string. I'm going to have, right, integer or floating point values. I'm going to have a description, okay, or I might have, say, a list of information. So very often in biology, we're going to have heterogeneous data, okay? So this could be a problem. My primary reason in, say, not using NumPy all by itself is that it also does not let me label my rows and axes, okay? I mean, my rows and columns. So they do have an integer, label, they do have an index, but I do not want to have to remember that my population information, is in index 4 as opposed to index 3. I would much rather refer to it by its name, okay? That is, we'll see, is one of the huge advantages of using pandas. Any questions about NumPy before we move on? So I'm going to save this and close it out. And so the next thing I'm going to do is come over here to this intro to data analysis with Python. And this gives us some information on the pandas package itself. I would say what I think is important is to talk about some of the key features. And so pandas does a lot of work with regards to, say, manipulating or just basically getting my data from the file that I have into a usable format. Okay? If you've ever looked or done much work in data science, you know that somewhere around, say, 3/4 to something like 80% of your day is spent just munging or cleaning up your data. Okay? That is something that pandas does a fantastic job of, as we'll see. Okay? So pandas works fantastically with, say, missing data. It has size mutability. That means I can add columns or rows or delete columns and rows very easily. I can get a bunch of capability by using the group by functionality. I have the ability to do, say, slicing, indexing, or subsetting, or grabbing a subset of my data very easily. I can merge and join it. I can reshape it. I have the ability to look at hierarchical labeling. That means that I can have more than one label for my rows or columns. Okay? And then I can deal with, say, time series data as well. And so what we're going to look at today, here, if you run this particular cell, this gives you an overview of the pandas web page itself. So it's at pydata.org. So if you were to type in pandas.pydata.org, as we see here, this is where you can get some information and certainly look at the documentation of the pandas package. So we're only going to scratch the surface today. That's all we have time for. But I hope what you'll find from this notebook is that you can cut and paste some of this code to utilize it yourself. And then if you have other questions, please take a look at the website and you can find the documentation. So one of the first things we want to do is, as I mentioned, we already have pandas installed. Okay? But how do I know that? Okay? The best way to do that, which is kind of counterintuitive, is to try and import a package. Okay? So in this particular case, if I come along and I say import pandas, if I run that code and it doesn't give me an error, then you've been successful, which is kind of counterintuitive. Okay? If you are having troubles, this line up here, is a capability that's built within the Jupyter Notebook, so you can go out to the Conda package distribution software that comes as part of the Anaconda package, and this is where you can update or install the pandas package if you do not have it installed. Okay? I can also go to my Anaconda Navigator, come under my my environments, and if I want to look at stuff that is not installed, I can type in pandas, but we'll see that the regular pandas package is not showing up here because it's already installed. If I want to look at installed items, I can see that pandas is installed on my system. This is also where I can do updates if I wish to, although I can do updates on the terminal and on the command line using Conda as well. Okay? How many times do you have to actually install pandas? Right? Once. That means that I have to bring the code from another computer, right, or from not necessarily GitHub, but from, say, the Python package index, or from where Conda stores it, right, their repository, onto my computer, but I do that one time. Right? How many times do I have to import pandas?
Every time you need it.
Right? Every time I want to use it, right, I have to import it. And I have to import it before I can use it, okay? And that aspect may not be entirely intuitive, right, if you're looking or using a Jupyter notebook, right? Because while I can import a piece of code at the very bottom of my notebook, right, if I then scroll up to the top of my notebook and run something, right, it will work, okay? But you must import, right, the code before I can use it. I mean, link to it is what you're essentially doing. So I have imported my pandas, and then what we're going to do is, in this particular case, we're going to look at what is the best example that I've found so far. It is weather-related data, but it is a mess, and it is a fantastic exercise in doing some cleanup and some analysis. Okay, and so I find that I actually refer back to this notebook on a regular basis, because I'm familiar with the code snippet, that I can grab it out and then use it in my next project. Okay. And so if we look at right, the head of this weather data, what do I see with regards to my data? What do I know about it by looking at this?
Header and about 20 columns.
So I see a header. It looks like there are what I'm assuming are column names, right? I see some data down here. It looks like there is some, right, some calendar, right, or date information. I see a bunch of numbers, and it looks like I have, right, at least a missing value here. But then if I scroll down to, say, the second, right, row of data, I see this odd letter T, and I see the word rain, okay? So could I easily, let's say, could I easily put this data in NumPy? I would say no, in large part, unless I were storing all of my data as a string, but I don't want to do that, okay? So that's the first advantage, right? The fact that I have heterogeneous data, I can use the pandas package, right? And it allows me to do lots of different work, okay? And so here, I have my CSV, right? My comma separated values, okay? And I can see that as well from the data here. Okay? If I run this command, okay, what have I done in that command? Right, in this command here that's incredibly nicely labeled 178. You can see I've run things a few times, right? So am I using an abbreviation for pandas at this point? No. Okay, so I'm just typing out the full word pandas, okay? And what method am I calling?
Read the CSV.
Right, I'm calling a method called readCSV, okay? And then I'm giving it, right, a single value, and that is the location of my data file, okay? This gets back to that old reason, right, why we have, so the command line class to begin with, is that I need to know, right, where my data is. I need to be able to find a path, right, to get to it. Okay? Unless, of course, I copy everything into, right, one folder, which I'm able to do, right, then I don't have to use, right, a thing like the word data here that tells me I'm looking at a folder within my current folder, right, for a data file. Okay? So I run this read CSV. I save it to this wonderful word data. Okay. So I have a variable named data. Okay. But let's look and see what has been created. So if I use the word or the keyword in Python, type, and I put in my new variable and I run that, I can see we've created what's called a data frame. Okay? So if you are coming from the R world, right, this is going to be very familiar to you. Right? A data frame is a two-dimensional array, right, or a two-dimensional list, right, with data in it. Okay? But one of the challenges, right, it's fantastic that, say, this pandas package is written for us. Absolutely fantastic. One of the challenges of having these packages written for us is how do we find out, right, what capability it has? Right? One of the ways is coming to a seminar like this. Okay? The other way is, say, doing a search on the internet. But if I come along and I say that I want to look at, right, my help for pandas, and let's specifically, let's see, let's back up just a second. I'm going to type in the word pandas, right? I'm going to use my dot notation, and that dot notation, right, I type a period, and then I hit tab. And what this does, right, this is a capability within the Jupyter Notebook, and it allows me to see, right, some of the capability or some of the methods that are in this pandas package. And so I come along here and I can see that, right, similar to what we saw in the NumPy package, right, there's lots of capability here. Okay. I'm interested in reading in some data, so if I type in read, I can see that there are a number of different capabilities to read in data. So we looked at the read CSV. I see that there's a read Excel, there's a read HTML. I look and I see that there's also, say, a read SQL. Okay, so there's a number of capabilities to read data built within pandas. Okay. If I want to get more information, right, on the read CSV, I can, right, type in the word help here. And if I type it correctly, right, and what this does is it embeds, right, that information into our notebook itself, right? And so the first thing I'm going to draw to your attention is this information I've selected is just the number of parameters, right, that pandas can take. Okay? So this shows you that, right, before doing anything, right, these are the capabilities that I have just with regards to reading in a data file. There is a huge amount of capability just getting my data in. Okay? But please understand that I don't have to use any of this with the exception of that first argument. Okay? We see here that every one of these arguments has an equal sign, right? And as we saw in our Python programming seminar, right, that means that there is a default setting. And if there's a default setting, I don't have to write anything there. Those are called optional arguments. Right? Remember that this first one is a positional argument. And so whatever you put, right, in the read CSV parameters, right, the first one is it's expecting, right, a file name. We see that by default, right, the separator is CSV, but the fact that there is, say, a separator option means I can change separators. Okay? Did you notice when we looked at the different read options, there is no read tab capability? Okay, at least named capability. So instead, right, if I want to read tab information, right, within pandas, then what I would do is I would use the read CSV function, and I would simply change the separator, okay, from a comma to a tab. Okay. But once again, to give you some, right, just some concept of how much information is available, right, as we scroll here, we see a number of different capabilities. Right, but this is also, right, a great place to look if you are wondering if pandas has that capability, or if you need, right, details or specifics on how to implement it. Okay. So we have, right, we've done a very, very simple import, right? All I've done is called the pandas package, I've called read CSV, and I've given it, right, the file name that I want to read in. But behind the scenes, pandas has done an immense amount of work. And so if I run this method called info on it, I see that a number of things have happened. Okay? First of all, right, we already know my data frame has been created. But what else has happened? Do you have any insight on your data just looking at the information?
There are characters and fields according to the types of data in each one.
Okay, so I would say the first thing that jumps out at me is that there is a long list of information, and I've done nothing short of telling it to open the file, right, to get that information, right? As we saw, right, at the very, very beginning here, when we kind of took a quick look at our data, okay, so it looks like the headers, right, or the column headers have been imported, and right, so I see that there are 23 columns of data. I see that there are, right, not quite 400 rows of data. It looks as though there's, right, some way of interpreting what type of data is stored in each of those different columns. And so down here I see that there are 4 different floating point columns. There are 16 integer columns, and then 3 object columns. Okay. What that object column means is that pandas couldn't give you any more information, right? And so it either is string information or it can't tell. Okay. Remember once again that everything in Python is an object. Okay.
Why are some columns indented?
Very perceptive. Okay. So what has happened is that, right, Python has done a lot of work, but it can only do so much. So as we will see, and if you look up here, you will see that, right, certain column names, right, occur with no separation, right, between the columns, between the commas here, okay, and yet some do. Okay, so what that means is that there is a space in front of some of those column names, and we will have to fix that later on. Okay, but what's interesting there is that that's not something you're going to notice in Excel, right? You're going to look at your Excel file, you're going to see a column name. It'll be great, it's got column names, right? Right, leading spaces or trailing spaces, those are all invisible and not necessarily something that I'm going to see, okay? But as you noticed, right, each of these different column names should be left aligned, okay? So one of the other things I can do, question?
One more quick question. How come on info you don't need parentheses? Sometimes when you call it.
So that's another great perception. So with regards to Python, that dot notation, right? If I am calling a method or a function, I must have the parenthesis. Okay, so that's what the distinguishing characteristic here is, that I am not calling a property of my data frame. I'm calling a function or a method within pandas, okay, called info. Okay, and so yes, so in that case, the Jupyter Notebook is helping me, right, by coloring, right, or giving me that context highlighting. Okay, but I do want to use, right, the open and close parenthesis, because if I don't, I will get, right, some information. What this actually is it's a property of it as opposed to a function call. And so the difference is going to be that, right, this is going to kind of summarize my information, right? Where before I was just looking at the info kind of in a raw format. Okay? So down here, this len, this length function, right? This is part of the Python programming language, right? This allows me to check the length of an object. Once again, here we see the collaboration between the pandas programmers, right, and Python language. And so they're using this standard capability so that I can come along and I can use my length function and I can get the length of my array, or I mean the length of my data frame. And in this case, right, we have the 366 rows that we saw earlier. Okay? So in comparison to what we talked about with the parenthesis, right, if I want to look at a property, that means a value of my data frame, right? One great example of that is this value called columns, right? So if I type in data.columns and I run that, then what it returns, right, is a list of all of the column names. Okay? This is something that I can change, but that is a property, right, that the pandas package builds automatically, right, when it's importing the data. Okay. So remember, all I did was simply tell it, right, the name of the file. Right. This is some of the work that we've seen that goes on behind the scenes. So based on that, right, I see that there is this first column called EDT. If I want to look at a column, right, I can do one of two things. I can call it by name using the square brackets. In this particular case, this looks like what type of information is being stored. Right, looks like some type of date information, right, is being stored, right? I may or may not know, hopefully if I have the file, I know what EDT is, right? But I can see that it's some type of date information. I can also, right, reference or call up multiple columns as long as I include all of those column names in a list, right, which is in a set of square brackets. And so here, the data frame, right, or pandas is expecting a single argument with regards to the column or columns, plural, that you're interested in looking at. Okay. So above, right, I gave it a single name, right, as a string. In order to include multiple, right, I must enclose it in a set of parentheses. So that's why we have, a set of brackets. That's why we have two brackets here, right? The first bracket is saying I want to select something from my data frame, right? The second of the interior set of brackets is saying here is a list of columns that I want to look at. And so if I run this, right, I see that I get a set of columns. Please. Okay, give me just a second. But what you'll also notice here is that there is a third column that's presented, and that is an index that pandas automatically creates, right, when it imports the data. Okay? And so that index is where this bold number, right, from 0 to the length of my data comes from. Okay? So that is one way, right, to look at or to grab out data is to refer to it by name. Okay? The other way to do it is by the dot notation that I've referred to. Okay? And then what I find very, very interesting here is that pandas has pulled in the names of those columns and has then set each of the column names as a property, right, of the data frame that I can call to get my data. And so if I call now, right, data.edt, I can see that it brings up, right, the same data that I saw before, but it's very nice to be able to refer to, right, the columns using that dot notation. So look at that for a minute. Let me see if I can solve this problem in the back. You're able to look at multiple columns using that bracket. Can you look at multiple columns for dot notation?
No. Not that I know of, no. So that is, not that I know of. Right, great question.
What happens if you try to, if the column names aren't unique?
That is a great question. Why don't we try that in a minute? And let's see. So part of what we see is, right, having that dot notation is fantastic in some senses. So here, right, if I want to look at just the top of my column, then I type in, right, the data, that's the name of my data frame, right? I type in the name of the column I'm interested in. And then what is also is I can continue, right, that dot notation. And then I'm going to call, right, this data.edt.head, right, that's similar to that Unix command that we saw, and it lets me look at just the top 5 rows of data, okay? As you would expect, right, I can go in and I can change, because we're calling head and head has the parenthesis, that means it's a function, and itself, right, has parameters that I can check or set. And so I can change, right, the number of rows that I want to look at. But each time that, right, what we want to take away here is that that dot notation, right, can continue, right, as we go through my statement here. So what I would see is that, or what I should understand is that when I call the word data, right, what I'm asking pandas or Python to do is to pull out that data frame or reference that data frame. When I use the period or the dot in the EDT, I'm saying I just want to, I don't want to look at the whole data frame. Now I want to look at just a column. And then if I continue that dot notation, what I'm saying is that using that one column, right, as input, feed it into this function, right, in this case head, and return only the top 10 items to me, okay? So I'm going from, right, my entire data frame to a single column, right, to an operation, right, on just that column information, okay? Now, if I choose, right, to not use that column, right, I can still call something like head, right, on my entire data frame, right? And so then in that particular case, I'm saying pull up my data frame, right, feed it into one of the functions, right, that is a component of that object, right, that the data frame has the head functionality built in, okay? And then let me look at, say, just the first 10 rows, okay? And then, if I'm going to anticipate your next question, right, I can also do the same thing here by trying, right, if I want to look at EDT, I want to look at max temperature, make sure that I have it right, MAX space temperature F, right, I can still, right, combine, right, the calling of multiple columns and that dot notation, okay? Let me confirm here, okay? So what we've done here is, right, I'm doing, right, a two or a multi-step process. I'm saying from my entire data frame, right, select 2 columns of data this time, okay? And then, right, what I'm saying with this dot notation is feed those 2 columns into, right, that method of head, okay? I think as we'll see below, I can also do things like, right, max, right? And so there is a lot of functionality built within pandas, okay? And so here then, if I very quickly want to grab, right, what is the max of any of my columns or of my entire data frame, I can do that, okay? Let's see. And then as you alluded to very much earlier, if I want to reference a column that I understand as being mean humidity, if I run that, I'm going to get this incredibly wonderful error, which is one of the longer errors that we've seen, right? And then down here, I get this semi-cryptic warning that says that there is a key error. That means it cannot find, mean humidity, okay? These are the kind of things that drive me insane, right? I'm like, it is mean humidity. I've spelled mean correctly. I've spelled humidity correctly. I put a space in between the two. I have done everything, correctly. But that is part of the problem of the fact that, there is that wonderful space at the beginning. And if I rerun this, then auto-magically, my data is presented, okay? So once again, pandas does an immense amount of work to help us, but computers are only as smart as they're programmed to be, right? Questions? Okay, so at this point, what we've seen is I can select, data based on a particular, a single column or multiple columns, and then I can feed, that information into, further capability. And then here, if I want to get, what is the second to last result, okay, what I would do is, I could say that I want to grab the length of my data, okay, so I could say something like, length of data, okay. If I do that, I'm going to get, 366, We have to remember that, the length returns the number of rows, but that length is not a zero-based count, So if I have one row of data, length is going to tell me, there is one row of data. Not that there is, that's the 0th row, but there is one row of data, okay? So this is going to return 366. What happens if I run that? I'm going to get an error. And so here what I'm doing is I'm saying that, what we have done is we have changed, the location of our brackets, So I'm using my data frame. I'm using a particular column name. And then all of a sudden, this is the first time that we've seen that the brackets, instead of occurring after the data frame, they're now occurring after the column information, okay? And so here what I'm saying is I want to look within this particular column, and then based on the integer that I give it, I want to select a particular row or rows. But if I try and run this, I'm going to get an error that says that there is no key, there is no index of 366, And I would say, let's see, oh, I need to do two things. I need to remember that Python is 0-based, so I'm going to subtract 1 from my column, from my length. And then I'm not looking for the last one, I'm looking for the second to last one, so I'm going to subtract 1 again. And then I can see there, that I'm selecting, the penultimate, the second to last row of my data. Okay. If I want the last row of data, I'm going to take the length minus 1. Okay. Does that make sense? So let's see. So we've looked at a number of our rows of data. What I can also do is we're in what I would call this kind of data discovery phase. I have some data. I've read it in. I can see that there are a bunch of columns. I can see that there are a bunch of rows. But now I want to start looking perhaps at individual columns, and I want to get a feel for how good that data is. Okay? One way that I do that is that I use this describe method. Okay, and so let's see here. I use this describe method, and if I run that, what that does is that takes the mean temperature in Fahrenheit, and that feeds that into this describe function. And then what describe does is what? Right, so it's gone through and it has looked at, right, obvious things like, right, the counts, okay? It gives me information on, here at the bottom, right, this is the name of the file, or the name of the column, right? It's a floating point number, okay? It's told me how many columns, and then it goes through and it gives me, right, some very easy or some basic statistics that say on the mean and standard deviation. But then what's also interesting is that it, right, gives me information on, right, minimal and maximal values, and then it gives me some information on, right, what are the quartiles, or where do the quartiles fall, okay? So what is the value that's at, say, the 25th percentile, the value that's at 50th percentile, right, the value at the 75th percentile, okay? So very quickly then I can see if, right, there is, right, some data that is, right, totally askew. Right? I can see if there are, I can't necessarily see that there are outliers, but if some of this information, say, doesn't make sense, or if my 50th percentile is 59, while my max is 1,000,000, right, then there's possibly an outlier in my data, okay? But this describe method, right, just very quickly gives me, right, some more information about the column that I'm interested in. Okay?
How will it handle null values?
I want to say it ignores them, but I would have to double check. And we will get rid of our null values shortly, and then we can recompute it. So for the time being, let's create a cell below. Let's look at data, and we're going to describe it. Okay. And so then here, right, I've called that same describe method, but instead of feeding it a single column or multiple columns, I feed it the entire data frame. Okay? What have we done? So, right, we've computed, right, that those describe statistics. Okay, does anybody remember what is the first column in our data? Right, EDT, right, is the first column. Right, is that represented in my output? No. Okay, as you would expect, right? That was what looked like date information. Okay, and so this describe method is skipping over, right, any non-numerical columns and only computing this information on numerical columns. Okay. And so then, right, if we save this, then we can go back and look at it and see if it's changing once we fix our null values, okay? So we saw a moment ago, right, that if I call the property columns, right, I can get a list of the column headers, okay? How do I know this is a property instead of a function? Right, so the fact that I'm calling the word columns, but there are no parentheses after it, there's no parentheses here, means I'm referring to a particular property or a value of the data frame, right, and not a function. They're not a method. Okay. What I have done is I've gone through and created a function that will clean up, right, these data column names and make them standard. Okay. This is something that, if you find it useful, you can cut and paste, right, in your code. And then all it does is go through and makes everything, let's see, lowercase, right? It replaces any spaces with underscores. And in this particular case, what it also does is it goes through and it left strips, right, or it removes any spaces, right, from the left. But what is interesting here is, how am I doing that, right? I'm doing those 4 operations, but in a single line of code, okay? I would say normally you don't necessarily want to do 4 operations in a line of code, right? Because it's going to make it hard to read. And so I could break this up, right, into 4 different lines, but I would say because of the name of the functions, right, and the fact that they're short and it's all fitting on a single line means that it's not as unreadable as it could be, okay? So in this case, what we would see is, right, I am looping through my columns, and each column, right, I am left stripping it, and what that left strip does is it takes a string, right, it removes any space to the left, and then it returns a string, okay? So then the way I would see is that left strip does its job, it returns a string, then it feeds it into lower, right? Lower takes that string, makes it lowercase, right? Returns a string again that I then can forward into replace. Okay, and so it's just basically I'm taking a string and then returning it, and then at the very end here, replace is going to replace those strings with underscores, and yet again, return a string as output, and that then is what will go into this new column value. Okay, and so what I'm doing is looping through a series of columns, this list of column names, and then what I'm doing is going and feeding it back into the data frame so that in this single command, I am cleaning up my column names, okay? And obviously you can tweak that as you need. It may make sense to add a right strip to it so that any spaces that are on the on the right side, would be removed as well, okay?
More than one data frame that you work with, you have to name it with
Great question. Here, because we have defined a function, I am taking a data frame as a parameter, and so if I have multiple data frames, let's see here, I am going through and I am calling that function, and so I can call it on as many data frames as I want. But please.
This function is not just affecting the headers, right? It's affecting every.
Great question. So it is. That's more of like a philosophical question. So it, in one aspect, it is only renaming the columns. But while I haven't looked at Pandas's code, what I'm assuming is going to happen is that once the columns are renamed, then all of the other references, are renamed as well. It's a great question. And so that means that the new names, will then be available as dot notation, not the old names. Is that what you're getting at?
No, I was asking let's say 50th element of a column, text, you could rename that as well.
No, so no, it is only taking, and the reason I can say that is because if I look at this line here, it is only grabbing the column headers and processing those. So it doesn't touch any of the data at all. Great question. So yeah, so then we grab the column names, that's a property, and then at the very end, before we exit, we reset that property, but the data has never been touched.
If you did have a number of data frames to put through it, can you put it in as a list as data, or would you have to do a for loop?
So right now, the way that I have written that particular function, you would use a for loop and just go through your different data frames. Yeah. But if you want, you can adjust that to take a list and check and see if it's a list of data frames and then process each one. So it would depend on, for the time being, I would say, that's a good question, because a data frame can be, a single file of data, and if I have, say, 5 different data files that I want to analyze, I could read in each of those, and then right, I would probably want to start either combining the data in some form, and so then you would need, right, some type of standard name, right? And so, but for the time being, right, it operates on a single data frame, but then I could loop through those different data frames. Yeah. Okay, but while that is wonderful and interesting, right, for our example, or what that does is that it right, semi-intelligently, right, adapts our data, or maybe not even semi-intelligently, right? It just simply right, changes, say, the spelling and removes the spaces. So the advantage of this function is that it makes all columns, right, dot notation capable. But something like EDT, right, it still is not going to fix or change, right? That still is an abbreviation that I know nothing about necessarily, okay? Instead, what we can do is, if I happen to know, right, that I'm going to be processing this type of data on a regular basis, and I would rather have, right, a set of much better column names, then we can do this, right? Here, I'm setting my column property to a specific list of column names, okay? So I'm changing every one of them. And then when I do this, and I rerun, remember, it doesn't necessarily matter the order, so if I rerun it here, then I can see that EDT is now date, right? Because I have renamed all of those columns, okay? That kind of thing I cannot necessarily, I can't do, right, automatically, but I can, if I'm using the same data, right, and then reprocessing a new version of it, then I can rename the columns like this, okay? If you want to, right, do that type of thing, but do it on less than, right, all of your columns, this is the, right, the context or the way that you would do that, okay? And so here, right, what we want to look at is the fact that we have gone through and, right, renamed all of our column names, right? We've done it manually or semi-manually at this point. And then what we see is that now all of our column names are now left aligned, okay? We now have a column named date, right? That makes more sense to us, okay? And so then here where we would have tried, right, I could not have used, right, the mean temperature before, I now have that available to me, and so I can look at some of the mean temperatures, okay? As I mentioned, right, there is lots of collaboration between, there's some collaboration, right, between the different package programmers. And so one of the capabilities that we have that is fantastic, remember we're doing data discovery here. We're trying to figure out, you know, some information on the data that we have. And so if I call this, right, matplotlib inline, remember that's part of the line magic is part of Jupyter, okay? And I tell pandas that I want to look at my data frame, right? I want to look at that mean temperature column, but instead of simply, right, computing some simple statistics about it, I want to look at, right, a histogram of that data. If I call hist, right, that function then, right, grabs that data, computes a histogram. By default, it's going to bin it, right, into 10 bins, okay? And then this, right, gives me, I would say, much more information about my data, right? From here, I can see that it looks like the information that I have, right, could be bimodal. If I want to, right, change, and we'll do it here, if I want to change the number of bins, right, I can look at a property, right, of that hist function and change the number of bins, okay? And so, you know, this graph is nice, right? It's nice for my information, but I can't really do anything with that, right? I don't know what my X values are. I don't know what my Y values are, right? I don't have any title information for that graph, okay? If I want to do that, right, add that information, right, I can very quickly come along, and as we will see in much greater depth, right, when we look at data visualization, what I'm doing here is I am using more of the functionality of matplotlib, okay? And so in order to enhance that graph, I have to do a few different things. One of the first things I have to do is I have to save the output from that hist program, okay, into a new variable, and I'm going to call that variable ax. Okay, in this case, it's for axis. And so if we, let's see, if I look at, I can do this in just a minute here. Right, I can type in, look at type of ax. But we have to, what happens if I run that now? I was saying I was expecting it to give me an error, but the fact that we have called it before, and I think ax is its default name, okay, means that we're getting some results, so I've been foiled. Okay? But what we do is we return what is called this axis subplot, or this axis, and that allows me to kind of work with some of the underlying structure of the matplotlib function, the chart. Okay? Here, to that axis, I'm going to set an X label, set a Y label, and set a title. And then let's say, so I can do all of that. And let's say for a moment that I'm really interested in, dropping this into a PowerPoint function, or a PowerPoint presentation, because I have a lab meeting, later this week that I want to use it in. Okay? To do that, I have to take one other step with matplotlib and create what's known as a figure. Okay? And the figure I think of as being kind of the canvas upon which plots are put. Okay? So on this particular canvas, I can put a single big plot. I can put a whole bunch of different smaller plots, but by default, I'm going to decide what my canvas is. That canvas in matplotlib lingo is called a figure. Okay? And so then when I run this, I see my plot. I see that I've got some information on what I'm actually measuring as far as the x-axis and the y-axis goes. And then not only that, I now have this PNG that's available for me to look at. Okay, and I can confirm that if I just list what is in my current directory. I can see that there is now this mean temperature that was created now. Okay, this PNG. Okay, matplotlib, as we'll see, will format your file based on the extension that you give it. Okay, so if I want to instead save it as a JPEG and I rerun it, then I can see, and then if I rerun this, I can see now that my my mean temperature histogram is now a JPEG, just as a PNG. Okay, so it's in that case, we've seen that it's intelligently using its extension, to base its format. Okay. Previously, we've seen where I can name extensions whatever I want, and it doesn't necessarily matter if I'm saving files. But in this case, matplotlib is using that information to your advantage. If I'm taking I'm just going to copy my code from up here. If I copy it and instead I want to do something like change the bin size, I can now do that. And if I want to resave it, okay, then what this does is just give me a little bit more granular formatting of my histogram. Okay, but I love this capability because it very quickly gives me an overview of my data, and it helps me to do it in a very quick time frame. Okay, using just a couple of lines of code, it seems. Okay. Any questions on that? Okay, it's actually 11 o'clock. You all want to take a quick break for 5 minutes? Okay, why don't we take a 5-minute break and then we can come back. Oh, no, don't worry. Please make sure you signed in. So thanks.
I tried to do pretty last week webinar, which I was actually with. It was not here.
I have not posted it yet.
Okay.
So
Do you need to have just to view it within NIAID or outside of the
So anybody can view it as long as they have the URL. Right? So I can get you the URL. We cannot make it searchable at this point, so you can't go into YouTube and you can't search for it and find it. But as long as you have the URL, then you can bring it up and view it.
If you could send it to me, that would be really helpful.
Yeah. Yeah. If you'll send me an email,
Okay.
then I will make sure to send that to you. Sure.
Question.
Please.
If you move up, so, higher, sorry. This, what, does it have to be DS or does it just, random name?
In that particular case, it is a random name. So that's a good question. So here, as long as this matches this and this, right, anytime DF is referenced, you're fine.
Okay.
So this is just an abbreviation to, to let me know that there's a data frame coming in. I can use the entire word data frame, or I can just use the word data. I can use whatever I want because it is local to that function.
Okay.
Okay.
But these hasn't been calculated, is it? Because this is the function, isn't it?
Exactly, right. And so, so by the fact that I have, I have not run it, right, because there's no number here, so I have not run this.
Right.
But even when I do run it, I still have not called it.
Right.
Right.
Okay. Okay. All right. Thank you.
Good question. Sure.
Yes.
Yeah, I do have one question. I wasn't able to bring up Anacon on the,
Okay. Give me just a minute and I can do that.
but it's mostly because I think because I'm not familiar with that.
Okay. Yep. Give me just a minute. I'll be glad to take a look at it.
Do you have time to create a redundant column name, or
What's that?
you have time to create a redundant column name and see what
I
or I could play with it some other time, but
let me see. Just a minute here. Let's try. So what I'll try is, so the question was, can you create redundant column names? And so if I just take, say, one right, as, say, max temperature, and I cut and paste it, and then I try and assign it, it looks like it assigns. So if I, let's see. So it looks like it is, right, allowing you to have, right, redundant column names. But then what happens if I want to max temp? Okay, And then what it's doing is when you call it, then it just returns, right, the list. That's interesting. Yeah, same here. So then what happens if you do this? Oh. Yeah, so I'm not sure how you would necessarily refer to, right, a single one of those, but that's interesting. Good question. So then I'm going to make sure that I.
Where did you use the index notation? Will that give you a key error?
That's what I just tried. I just tried this.
No, I mean if you did like data bracket max them.
Oh, let's see. So that would be 2. Right. I'm not sure. Let's see. I'm going to go back to this data.
If you say data in bracket 2, is
So good question. I would think so, but you actually have to use a separate functionality called iLoc, or like index location, to search by row by index. And so so in that case, it is thinking that you're naming a column the number 2. And that's why it says there's a key error. Right? So it has a separate way of selecting by rows, and we'll see that shortly. Okay. Okay, and then you were having trouble bringing it up. Okay, so let's continue. We're looking at essentially some data discovery, right? Trying to find out some information about our data and clean it up. Okay? In some cases, right, we have data in, say, a different format than we really need it to be in. And so we want to look at, right, how we do, say, what's called bulk operations with this fantastic function apply. In this case, if we look at, right, our date column, right, that's that first column, that EDT column that we renamed, okay, we see that it looks like it has, right, some information, okay, but you also see down here that the data type is still labeled just as object, okay? What that really means is that, right, Python or pandas doesn't have enough information to get any more specific about what data is stored there. And so if I go in, and in this particular case, I want to look at a particular value, right? So I'm going to, right, grab a particular value, and what we're going to do is we're going to use a single value to figure out how to, right, correct it or reformat that data, and then we can do it on all, right, of the data in that column. So here I'm going to create a new variable, right, called first underscore data. I'm going to call, right, my data frame. I'm going to call the date column that we've been using. And in this case, I'm going to use this new functionality called values. I'm going to grab the first value in that column, okay? And that gives me this, right, 2012, what looks like March 10th, okay? If I were to come down here and I were to say what type, right, is first data, first date, I see that, right, Python understands that as a string, okay? What we're interested in doing is reformatting that into a specific type of data or specific type of object called a date time, right? This is a Python, right, way, that's something that's built into the Python standard library, a way of representing date and time information, okay? So from here, right, date time has a lot of capability built into it. And so what we're going to do specifically is call a particular part of that module. So we would say from date time, right, from that whole package, right, we just want to call one subset of that functionality itself called date time. Okay. And then what we're going to do is we're going to use a specific function or method of that module called, right, string, right, or strp time, right, it converts from strings, right, to a date time function. And then what it's expecting, right, two different parameters, different arguments. Here it's saying what data, right, do you want to change? And then, right, please tell me what you understand, right, the format to be in. Okay, and then we're going to use this code, right, that it has. So we're going to say that there is a, right, a $y. So the first thing is some year information. Then I understand that there is a dash in it. Then there is a %m, right, that's going to be the month information. Another dash, and then a %d for day, okay? Notice that we're not specifying 1 column, 2 columns, 4 columns, right? All we're specifying is what we think is the year, month, and date, and then it's separated by, right, the hyphens. And so if I run this, then what I see is that, right, it has returned a new object. It's no longer a string object, right? The date time function or module has now gone in and converted it to a date time, and that I would read it as, right, the year, month, and date, and this is, say, the hour and minute, and because we did not specify, right, it just automatically sets that to 0. Okay? So we now, right, have come up with a piece of code that allows us to convert from a single string, right, of our data to the date time object that we want. Next, what we'll see is, right, this magic, right, of this apply function, okay? What is wonderful but different around pandas, or different about pandas, is that you have to begin to think not so much in rows about your data as you do about columns. And when you are manipulating your data, you don't manipulate data one row at a time for the most part. Okay? You manipulate it entire columns or entire data frames at a time. And that's what took me a while to get comfortable with. And so here, I am defining a function. I'm defining a custom function. It's going to take, right, a date, what I'm calling a date string. I'm going to, right, simply paste in the piece of code that we just wrote above. Okay, and then I want to return that, right, every time this function is called. It's going to take a string that's some type of date information and return a Python date time object. Okay, so very, very simple one, right, line function. But what is incredibly powerful is that I can apply that, right, to my entire column by using, right, this pandas function apply. And so this is, it's almost, it seems very odd. Look what I'm doing here, right? I have my data frame, I have the column, right, that I'm interested in looking at, right, or I'm interested in changing that format. I have this, right, this keyword apply that I've mentioned, and then I am not feeding in an individual, right, value. What I am feeding it is the name of my function that I want to apply to that entire column. Okay? So this here, this string to date must match, right, the name of my function here. And then what you'll see that I'm doing is I'm actually replacing, right, that entire column. I could save it to a new column if I'm interested in, but I'm not interested in that. I just want to replace it, right? I'm converting that column to date time. And then what I'm going to do is I'm going to look at, right, the top here. And so to a certain extent, it looks like it did all this wonderful work and nothing really changed. Okay, so if I scroll up for a second, right, I see that here's my information before. I have what looks very similar, okay. One of the first clues I have is that my month, right, is now in 2 digits, right? So it's a standard number of digits, it's 2 digits. But most importantly is I see that the date type, right, is now date time from a Python perspective, okay? And so what is nice now is that if I were to go back to my data frame, right, my data, and call info on it, okay, I can see that it now understands, right, that first column is a date time column. I can see down here that I now have, right, a single date time column, and now I only have, right, two object columns where we had 3 before, right? So this is kind of halfway to what we want to do, right? In large part, we're working with data, right, that is date-based, okay? And so the next thing I'm going to do is I want to, right, utilize as much of Pandas's functionality as possible, right? Another way of doing that or enhancing what we've already done is to, right, change my index, right? Remember, what did I say the index is by default? When I print out my data, right, I've asked it to print out a single column, but I'm always getting, right, this 0, 1, 2, 3, 4, 5, right? That is the index information that Pandas automatically puts on there, right, if I do not distinguish an index at the very, very beginning, okay? Remember when we looked up at the top and we saw all of the functionality that Pandas had just within the open function? Let's see here. Let's come all the way up into our help, okay? So here, right, I see that there is an option for, right, an index col, or index column. As I'm importing my data, right, if I know what index I want to use, I can specify that at the very beginning, okay? But the problem with doing that in our case is that it would be setting that index, right, to the string values of dates, not to date time objects, right, which we'll see has benefits in just a minute. Okay? Does that make sense? Okay, so here, right, when I read in my file, remember we just read in, right, our entire code to read in our file is a single line, right, a single function that's read CSV, and all I gave it was the location of my file. Pandas brought it in, right, it picks it all apart, but because we have not specified an index, then it automatically generates one for us, which is just an integer number, okay? What we're interested in doing is now that we have gone in and we have, right, reformatted our date information, I'm going to scroll down here. Okay, we have reformatted our date information. We want to make greater use of that, and we'll see in a few minutes why. Okay, so what I'm going to do is I'm going to come down here and I'm going to tell, right, Pandas that I want to reassign one of the properties. Remember, we're not dealing with a function because we don't have the parenthesis. So the property is the index, and I want to set that index or replace it with the date column that we have. And so now what we'll see that's different is it tells me that I have a date time index, and then Pandas automatically has done more work for us. Okay, so now it's saying that not only do you have a date time index, but the data that you have in your data frame starts on March 10th of 2012 and goes all the way to March 10th of 2013. Okay, so it's already getting, right, more context from that information. Okay, as a matter of fact, and then we also, right, we still have our date column. So the next thing we're going to do is we're going to drop, let's see here, I'm going to drop my date column because I don't need it anymore. Okay, and I can see that when I print out columns, right, I have deleted that. I'm going to move this up here a little bit. Okay, and so this allows us, right, this gives us a number of, right, advantages. I can now search my data, right, by date, And so here, if I want to look at, right, a particular date time, right, I must feed it in a date time object in order to do that. Okay, I can select a particular date of, say, August 19th, and I can find out, right, all the data that was collected on that date. Okay. I can do, as you were asking, right, I can search by particular rows, but I must use this functionality called iLoc, or index location. And in this case, I'm going to give it a range, right, of, say, I want to look at the, right, is that the 7th row? Or is that the 8th row? If I'm asking the question, right? If I'm asking the question, right, that's the 8th row. And then what we would understand is that it goes up to and up to, but does not include, right? So it's rather interesting, right? When we look at these ranges with the colon in Python, it is it's exclusive, right, of the start, and then no, inclusive of the start and exclusive of the end. Okay, and so here, if we look at our data, we would see that this would be the 8th position, the 8th row, right, up to, but not including, right, what we would understand is the 15th or the 16th row. Okay, but our take-home message is that if I want to do, right, searching or filtering of my data, I can do that using, right, iLoc for index locations. Okay. And then, right, if I want to, this is.
Yeah, I thought you replaced your index by your date. I thought it's actually eliminated the other one.
Great question. So I did replace it by dates, but there is still, right, from the pandas perspective, I can still refer to it by an index number. That is just not the say, predominant index at this point, right? So that means that each of those dates, right, still has an independent index, right? But when I look at it, everything I see is that date time entity, right? That's a great note. Okay.
So when you use the drop method, you have to create a new data frame instead of just modifying?
No, I don't have to, and I don't think I did.
Yes, I did, right? So data equals data.
Okay.
Drop.
Just
modifying it.
Great point. Thank you. So then here, right, with pandas, you can do 2 different things, right? I have the option many times of doing it in place. And so if I were to set an option and say in place equals true, and I believe it's called in place, right, then that would negate the need to reassign it. Okay, but in this case, I'm just I'm dropping it and then reassigning it, right? But I don't, as long as I use that in place option, then I can operate on the same copy that I have, right? Which, depending on how large it is, right, may be beneficial, right? Because then I don't have to copy a huge amount of data to a new location, right? Great question. Okay, let's come on down. We're going to look at the last part within exercise 3 is how you look at a date range if you're interested. Okay. But what I'd like to do is to move on. Okay. Here, what I'm doing is I want to count, right, the number of rows of data in each of my different columns. And I want to do this because I noticed that the second to last column, right, doesn't have 366 rows of data. It has 162, so there's some missing data there. So what I want to do is, that is my events column. Okay, I want to take a look at my events column, and I can see that, right, this is where that one of those text, right, those string words that we saw at the very, very beginning when we previewed our data, right, where the word rain comes up. But I also see that there is this NaN, which is actually a NumPy, right, object itself. It stands for a null value, okay? And so I can see that there is, right, this null value, but I would say, first of all, it makes it hard, right, to gauge, right, how much data is in there when I look at it. And then perhaps, right, I want to, right, change it so that when I do other work, right, at this point, this is a NumPy object. And remember, this is also the, one of the things that, right, pandas didn't have much information about, right? It's not saying that that's a string object. It's saying that that's a generic object and it can't get more information, right? That's because there is a mix of strings and NumPy, right, null objects in there. So we want to get rid of those NumPy null objects, right, and make it all just string data. So I'm going to do that. And so pandas has a function built in, right, called drop_NA. And so I'm going to call it, and I'm going to say that I only want to call it, right, I can call it on the entire data frame at one time. In this particular case, all I have to really worry about is this events column. So I'm going to say that I want to look at just, right, this particular column called events. I'm putting that in a bracket. That way I have the ability to, right, list multiple columns if I want. And then what I'm going to do is I'm going to call info again. So actually, let's do this in 2 steps here. Okay. So I'm going to drop the information. I know I'm not. Let's see. I'm just going to go back. So a series, from a pandas perspective, is one of the 2 dimensions, right? So a data frame is it's a series of series, right? So you have kind of a list of lists, and so then if we can't do, right, if we can't compute it on that, then we'll just go back and we'll just say info. Okay. And so then here, what we have done is we have gone through and, right, looked at only events where there's data in it. Okay, we've dropped all of our NAs. And then the next thing I want to do is I want to fill all of those empty cells with what is called the empty string. Okay. So there is no information there, but from an object perspective, right, it's a string object that has no value. But that is still different, right, than a null object, which is, right, no object that has no value. Okay? So here I'm going to fill in NA and then call my, right, my head again. And so here, right, now I can see that I have, right, I'm still my object column, but I've gotten rid of, right, all of those values. And so I've just simply, right, set all the null values, right, to the empty string. Okay. But when I run counts now, right, I can see that the events column no longer returns, right, 162 rows. It now is telling me that there are, right, 366 rows of data, similar to all of my other columns. Okay. So that drop NA and that fill NA functionality, right, are built within pandas and allow me to clean my data. Any questions on those? Please. Okay, just a minute. I think, did you have a question?
Is it still an object, or is it now string type?
So let's take a look in just a second. Okay, question?
I was not sure if you need to drop or you could just replace. How to drop it? I didn't follow why you need to drop it.
Good question. I'm not sure that I know the answer. So let's see a little bit later if we can. We'd have to restart, right, and reload our data frame. But we can try just filling NAs and see if that works. I'm not sure. I haven't tried that, but we'll see if we can try that. But I'll do that. Let's do it at the end so that we can keep going. okay? And then as far as let's look at our data.info. So for whatever reason, right, the events column is still labeled as being an object and not string. And I'm not sure why. Okay, but we're going to work with it more in a minute here. Okay. And so for the most part, right, I said that we don't necessarily work right one row at a time. Okay, there are some instances where we want to work with, say, a subset of our data. Okay, and we're going to see that right with this events column. So in this particular case, if I want to go through and I want to count the times, right? Let's back up for a second here, and let's look at our data, right? So what do I see, or what can I tell about our data in the events column?
Compound, multiple.
So this is like the quintessential like biologist like spreadsheet where I intended right to put just events in there. Well, you know, the events, and then we'll see this in a few minutes when we look at the amount of rain and a trace of rain right in a column that is meant for a number, right? This is why I gotta love biologists. You're like, well, I understand what you really meant, but you know, it's really hard to accurately describe the data given what limitations you've given me. So instead, in my spreadsheet, I'm just going to start compounding things, and right, this is where at least they spelled thunderstorm correctly these two times, right? So, so if I'm having to type this information, then that adds another level of complexity where my spelling is going to change, per day. But you're right. So here we see that there are days when there was just rain, right? And so that I suspect there was some type of protocol, and it says, right, log what type of weather you see each day, right? And so the measuring the temperature, right, you can do that. But here where there are going to be days where it's just rain, other days where right, somebody thought, well, there's rain, but there's also thunderstorms. Right, this day here we see that there is fog that day and thunderstorms. And then if you continue down, right, we'll see that there are other right things that were measured as well. But the important thing to understand is that it's not a single value, right, and that we can have right combined values, okay, which can be a problem if we're trying to do some data analysis. So what we would like to do, let's see, one of the first things we're going to do is we're going to look at this particular code here. This is allowing us, right, to iterate over the rows. We're using this iter row function, right? And then I am, right, each time I'm iterating over these rows, I'm grabbing two pieces of information. I'm grabbing kind of a generic index, right? And then I'm grabbing, right, my row. And then in that, right, row information, I want to look within my events column, and I want to know if the word, right, rain occurs in there, right? So ultimately, somebody said, right, here's your data file. How many days of rain are there? And you're like, I don't know, right? I could search in that column for just the word rain, but what happens with those compound values, right? So while storing the data was fairly easy, right, trying to do some analysis on it is proving challenging. So how do we get around that? So here, right, if I loop through, right, my rows, because this is one way of doing it, we'll see right, another way, or I would say a better way, right, a more pandas way to do it in a minute. I see that there are 121 days that have, right, the word rain in it.
Why didn't you just type print for it to return?
What's that?
Why didn't you just type print for it to return?
Excellent question. That is because the Jupyter Notebook, right, is helping us again. So normally I would. So the question is, why don't I have to type the word print here, right? And that is because we are using the Jupyter Notebook, right? So the Jupyter Notebook is taking that output and it's automatically, right, printing it for us instead of us having to do it. The challenge with that, especially as we are learning Python, is that this previous code here, let's see here, right, this previous code, if I copy and paste that into a Python script and run it through the Python interpreter, right, not the IPython interpreter, but the regular Python interpreter, it's going to give me an error, right, because it doesn't know what to do with that information. I haven't explicitly told it what to do, okay? And so then for demonstration purposes, if I type in the word print, right, it gives me the same thing. We see that, right, there are no parentheses, I mean, there's no quote around it as I get from the Jupyter Notebook, right? Okay, so we'll come back to that in a minute, right? We're going to do some more work on events. Before we do that, right, let's look at, right, we were trying to, right, filter our data based on that text values. We can filter our data, right, based on numerical values. And so in this particular case, right, if I am, I'm interested in finding out, you know, what days are freezing, what days are cold, okay? In this particular case, I'm looking at my data frame, right? I'm looking at a particular column, right? This is the max temperature. And so what days was the max temperature, right, not over 32 degrees? I can run that, and this is very important. What information is returned from that? It looks odd. So I have my new index, right? But then there is this other column, right, that looks like it's, in this case, it looks like it's almost all false. Okay, I do see a few trues, okay? I would say this is, right, one of the very, very important things to understand about how pandas and filtering works, okay? The pandas filtering is in essence, a two-step process, okay? When I enter this information, right, of max temp, and I give it, right, a conditional value, what pandas does is it, in its first step, is it goes and it evaluates every row as being true or false based on the condition that I give it, right? This is the information that we have here, okay? The second step is, that's not really what I'm interested in, right? I don't really care whether it's true or false. I really want to look at the data, okay? So what I have to do then is I have to feed that command, right, that conditional, back into, right, the data frame itself. And then it goes in and it takes all of the positive rows, if there are any, of course, and then returns that information. And in this case, we're going to save it as a what? What is the type of object that we're saving in freezing days here?
The new data frame.
It's going to be, right, a new data frame, exactly. So I'm going to run this. I'm going to get the information, okay? And I see that, right, I have, right, a new data frame, right? The values in that data frame are only those rows, right, that where the max temperature was less than or equal to 32 degrees for that day, okay? And then how many rows of data did I pull out? Right, 21. So I have 21 rows that had a max temperature of less than 32 degrees, okay? Right, as a matter of confirmation, right, if I type, if I use the keyword type, it tells me I'm working with a data frame, okay? But, right, in our, right, imaginative scenario, I'm not only interested in days that are, right, where the max temperature is freezing, I want to delineate that a little bit more. And so I also want to look at days where the minimum temperature is greater than 20 degrees. And so I'm going to do the same thing, right? But what's interesting here is that I'm now using, right, my new data frame. I'm using the dot notation, right, to look at the minimum temperature. Right? I'm doing some type of conditional comparison, right, greater than or equal to 20 degrees. And then what is that going to return?
Another data frame.
If I type in just this information, right, what will I have? Right, once again, right, that's that first step in the filtration, the filter process, and I'm only going to have, right, pandas is going to go through and filter at each row based on, right, true or false, okay? Then I take that, feed it back into, right, the data frame that I'm searching, okay, and in this particular case, I'm going to save it as a third, right, data frame. In this case, we're going to call them cold days. Okay, so I'm taking, this is a two-step process. I'm finding, right, days that are where the max is less than 32. Okay, then secondly, I'm finding days where the min is greater than or equal to 20. Okay, but that is, right, two-step processes I'm not really that interested in, right? I would rather be able to, right, combine these multiple conditions. And so, see here, if I look at my cold days, I can see that, right, in fact, I have, right, some data here, okay? But what I would much rather do, right, is to combine those conditions, right, in a single line of code. So then here I'm saying, right, my data frame, right, with my first condition, the max, right, the exact same thing that we computed before, right? This computes, right, true or false for each row. Then we take our second step, right? Once again, right? This computes true or false for each row, and then we can combine those, right? And then I put parentheses around each of the conditions, and then once again, right? That is going to evaluate to true or false, and then I feed that result, right, into my data frame, right, to get my data. Right, and so what that demonstrates is that I can, right, combine any number of conditions that I want, right, to, right, subset or filter the data that I'm interested in. Any questions? So at some point somebody was asking, right, what happens if I have a limited number, right, of things I'm interested in, right? I'm not necessarily interested in greater than or less than. What if I have a subset of data that I'm interested in? If I'm using, right, in this particular case, I'm saying I'm creating a new list of, in this case, gene names that I'm interested in, right? If I were to come in, right, this doesn't necessarily make sense, right? I'm not searching for gene names, right, in my temperature data. But here, right, I could search for right, max temperatures of 32, right, and 31. And then we would want to, right, remove this and just search for the integers, right? Then if I do this and I'm using, right, this new capability, this is in functionality, right, to search for, right, particular, right, subsets of data, okay? Then here I'm finding, right, only data that fits, right, the two criteria that I'm interested in. Okay. Let's see. And then, right, this is where we're creating data frames, and the only thing that we're doing different here, right, is that instead of, right, creating those data frames, we're showing, right, that we can actually, right, combine, right, data frames themselves instead of looking at individual rows. Right, so here I'm creating, right, a temperature min data frame. I've created, right, a temperature max data frame using the same criteria that we saw before. okay? No, so I'm creating, right, these are the series of information, right? This is just the positive or negative, I mean, the true or false values, right? And then I can compute, right, on those true or false values. And then, right, I can apply that. I can use that information if I wish as well, okay? So it's just a separate way of doing, right, what we've already done. Let's take a quick look. Let's see. Right, but we're working with, or what is returned, right, that true or false is a series, right, or a single dimension, as opposed to the 2 dimensions that we've looked at. Let's see. This is a slightly more complicated way of trying to explain, right? So in Python, there is this magic word called lambda. And I would say it's one of the more, right, conceptually difficult things, but what it essentially does is it says, define a function without defining a function, okay? And so here we see that I am, right, I want to apply, right, use this apply word that we saw earlier. So in this single line, right, I am combining, right, where I looked for the word rain earlier, and ultimately I want to just pull out, right, what rows have rain in it. I can do it in this single line, but I would say the question once again is readability, right? Does that, if you look at that quickly, does that immediately tell you what it's doing? And I often with lambdas seem to get an answer of no, okay? It's very quick and short to write, but I would say then we suffer perhaps in readability. But right, we can in fact get, right, to the 121 rows, right, using that. Okay. The challenge with lambda is that you have to create your function, right? This is the function here is rain in each of my rows, right, or make E in a single line, right, which can be more challenging. Okay, so we've seen how to do, right, the apply. As I mentioned, let's take a look here at this other row here called precipitation. So I mentioned earlier, right, that you've been given this spreadsheet. I expect in the precipitation column that you very simply, all I want you to do is just put down how much rain occurred that day. Okay. Well, I live next to 2 meteorologists. I'll have to ask them about this. I suspect that, right, if there is a trace of rain, right, I cannot in good conscience put down 0. But when I look at my instrument, it doesn't give me a value. So naturally, in my Excel, I'm going to put this word, this letter T, okay? I've done my work. I told you there was a trace of rain, right? Then I'm going home. How do we deal with that, right, in this column? So if I look at this precipitation column, pandas tells me that that is an object, right? What type of data is stored there, should be stored there? It looks to me like floating point data, right, was the intention there. But I have this problem. I have this value T that's messing everything up, right? So how can I use pandas to help me? What we're going to do is we've seen, right, apply. I can create a function, right? Sadly, there's no way around something like this. This is a custom occurrence, right? I have a letter when it really means a value. And so how do I go in and interpret that? From my perspective, I would say a trace of rain is just a really, 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 really small amount of rain, but it's still not 0, okay? So what I'm going to say is that anytime that we encounter, right, this letter T, that I'm going to give it, right, a value of, right, 10 to the negative 10, okay? And so I'm going to write my function, right? I'm going to call it precipitation to float. I'm expecting that there is going to be some precipitation. I'm expecting it to be a string, okay? Remember, this precip underscore str, right? That is my designation of the value. Okay? I can call it whatever I want. Okay? Here I'm going to say if, right, that value equals capital T, then what I want to do is I want to return this other value, right, this decimal point value. Otherwise, I simply want to leave, right, the information alone. And that means that's where this return is. I'm floating, right, the information. But because this is an object and we still don't know, right, or if it's represented as a string at this point or what, I'm going to kind of err on the side of caution here and then convert it to a floating point number, right, before I exit. It's like, while I'm in here, why not do this? Then I'm going to call my data frame. I'm going to call it on my precipitation column only. I'm going to use the word apply, and then remember, what am I feeding into that apply function? Remember, this is one of those unusual cases where I'm feeding a function right into another function. I'm feeding my function called precipitation underscore to float right into the function apply on a single column. And then when I do that and I look, then what I see is that, right, that pesky T has now gone away. And not only that, but now, right, pandas understands that that is now a floating point column. Okay. And this is just in two different things. So at this point, I have, right, my data, right, nicely formatted. Okay. If I want to look at, right, my, right, this is a particular, another column, right, called cloud cover. I can see that there is, there looks like 8 different values, right? So in this case, what we're learning about or we're seeing here is this group by functionality, okay? So we are taking my data frame, right? I'm grouping by, in this case, only a single column, okay? And then based on that, I am, right, looking at what is the mean value of mean temperature over those 8 different, right, unique values for cloud cover. And so it looks like there may be a trend, right? So I can see from this value of cloud cover 0, right, to the value of cloud cover 8, it looks like, right, the temperature is perhaps decreasing, right? These are the mean temperatures that I'm taking, right, the average or the mean of. And so if I look at, if I now, right, want to group by, right, I've gotten a hint that there's some information or some, right, trend to my data. Right, is there any combination, or can I see anything, right, in relation to those events that we saw earlier? And so here what I'm doing is I am using this group by again. But once again, you'll see that, right, the group by is expecting a single parameter, okay? I can use multiple columns, but I must put that within a list to feed to group by. And then what I'm doing is I am grabbing out 3 different pieces of information, right? I'm grabbing out what is the value of cover. I'm grabbing out what is the value of events. And then I am pulling out, right, this group data, and that is basically how many rows, right, are part of that. And what I'm really interested in doing, right, is just figuring out how many occurrences there are. Right? So here I can see that there are, right, 99 occurrences where the cover is 0 and there is no event. Okay? If I come down here to the very bottom, I can see that with cover 8, no event has a lot less values, right? It has 5 values. But I can see that, right, the most often occurring thing down here is with cover 8 is, it looks like rain, right? That occurs 11 times. And so over the course of, right, these different events, it looks like the number of, right, just blank counts is decreasing. And then we see that there is an increase of things like rain, snow, rain. I have fog rain. Okay, so it does look like there is some correlation perhaps between cover and events. But it's still that events is still causing some error. It's hard to get pull it apart. And so if we look at events, and in this particular case, we're calling this unique function. That's right. I only want to look at what are the unique function or the unique values within that column. And so I see that there is this empty string. I see that the word rain is occurring by itself in addition to things like fog, rain, and thunderstorm. And so it looks like I have almost every combination of rain, thunderstorm, snow, and fog. Okay, in some case, all of them happening together. Okay. What I'm really interested in doing is, because I have this fantastic data frame and I have the ability to compute things over an entire column or all rows very quickly at one time, what I would really like to get at is I'd like to have individual columns for each of those different events. Okay. And then if I want to combine them, if I want to look at rain and fog, I have the power to do that. But in order to really get at the data, I want to separate it all. The way that I do that is I'm going to create a list of values. These values are taken directly from the information here that I got from unique. I see that there are 4 different unique values. Okay, rain, thunderstorm, fog, and snow. So what I'm going to do is I'm going to create my own loop to loop through those 4 values. Okay. This is a shortcut, to let me do that. If I want to create a name for this list and then use the name of the list down here, for event kind, I can do that, but this is a shortcut. And I'm saying that, every time, or I'm going to, let's see, we're going to create the lowercase version of it, excuse me. And then what I'm going to do is I'm going to use this functionality here, this data, that's my data frame name. And then I'm going to create brackets, and I'm going to use this column name. So I'm going to create a new column for every type in this list here. And then I use that, that lambda function, and I simply go through and does the word, rain or thunderstorm or fog or snow occur in that field? If so, then we're going to add a true or false to a new column. At the end here as confirmation, I want to see that I have in fact created new columns. And so I can see that I have 4 new columns, and they are what type of column? They're Boolean, that's a true or false value. Okay. And so then if I go in and let's take a look at rain, I want to look at that rain column I just created, and I can see that I have false and true values. Okay. As we would expect, I can go through and I can look at combinations. If we want to rebuild the fact that I'm interested in looking at, say, a rain thunderstorm combination. Okay, and if I want to look at what are the totals there, then I'm going to create a new data frame, called new underscore df with just the rain and the thunderstorm in that data frame. And if I call sum, then very quickly, and I would say intuitively, I can see that there are 121 columns that had rain in it, and there are 45 columns that had thunderstorm recorded in it. Any questions? Does that make sense? So I've separated out my data into new columns of true or false values. And then instead of going through, right, and counting the word rain or counting the word thunderstorm, I'm simply counting whether or not, right, those values are true or false. Right? In this case, I'm summing, right, the true values. If I come and I sum all of the true rain values, right, I can see that that in and of itself, right, is 121. And then, as you would expect, right, if I come along and, right, because those are Boolean values, right, then I can do what we had done before with our filtering, okay? But I can say if I want to find, right, only rows, right, where it was raining and it was snowing, then I can combine, right, the data.rain, the data.snow, and call my info, and I can see that there are 7 days, right, where both of those events occurred. Okay? I would say in large part, that is very readable, right? I can see what is happening there, especially if I'm following my workflow, but right, that is not incredibly difficult to read, right? I mean, it's fast to compute. Right? Questions? Y'all okay? Okay, we've got a short time. Let's look, I'm going to skip over that. I want to look at some plotting functionality. Okay. So here, I am calling, right, data dot, I'm looking at the max temperatures, and I'm calling the plot function, right? Beforehand, we saw what graphing function? We saw a histogram before, right? Here, right, we're using this, I believe it's the PyPlot capability, right? We've already imported it. We only do that once, remember. Here, I'm calling plot, and so by default, what it's doing is it is showing me right, max temp information, okay? What is an important difference about this chart? It's showing me fluctuations, okay? So that's, yes, I should rephrase that. What is important and different about the axes on these charts, on this chart? Exactly, right? So you were saying that because we have changed my index, right, to the date time values, right, my plot is now, right, automatically showing me, right, the date time information, and it's formatting that correctly. Okay. So here I can see that I'm looking at, right, March to March, and I can see that it looks like in January that there's the new year 2013. So I'm looking at the range, right, from the previous year from 2012 to 2013, and that is my date information. Okay, that is simply based on us, right, correcting or changing that index. Okay. And then of course I can see that, you know, as you would expect, right, over the summer months, right, the maximum temperature increases, and then over the winter months, it looks like it goes crazy. Okay. But what is interesting is that in this particular case, right, I am plotting all of my max temp information. Okay. With pandas, we've seen that I can select, right, a subset of my data. Okay. I can also take that subset and plot just that subset if I'm interested. Okay. So in this particular plot, if I want to look at just the last few maximum temperatures, okay, here, so I'm looking at, right, I'm grabbing the tail information that we saw earlier. Right, let's remove this for a second. All right, let's see here. Right, I know that tail, right, shows me the last 5, right, numbers. If I take that command, right, and the data that it will automatically return, and then call plot as a dot notation, right, at the end, right? So what we're doing is we're starting at the right with our data frame, right? We're selecting a single column max temperature. From that single column, I'm selecting, right, whatever tail command is, that last 5, right, data values. And then from that, right, I'm importing that into this plot function, and then I plot, right, just those last 5 values. And then once again, right, I have my date information that is correctly displayed. Okay. I can, it looks like I am going through, and it looks like somebody was asking a question of what happens if I, right, in the Unix and in the head and the tail command, I can get the top of a subset, I can get the bottom of a subset, but there is no necessarily, right, middle command. And so here, if I want to look at, right, let's say the middle 100 values and plot that, I take tail of 200, right? That means I'm grabbing the bottom 200 values. And from that, right, that passes to the right. And if I take the head 100, that means I'm taking the top of that subset and then just plotting that, right? So that gives me the capability of, right, selecting a number of rows, in this case based on position, right? Right, as you would expect, right, plot is a function in and of itself, right, and has lots of capability built within it. So here we see that I'm taking the exact same thing I did a moment ago, right, my tail, but instead of, right, this line plot, I'd like to look at a bar plot, and then I want to also right, change the way that my date information is displayed. And so I'm rotating it, or ROT, by 10 degrees, and that allows me to look at, right, the date information. And then in this other example, right, we're using our axis as we did earlier. Okay, so we already have our right, our X axis labeled. Our Y-axis is not labeled, right? But that's going to be temperature, and so I can go in there and I can say I want to label my Y-axis, and then give, right, the plot a title itself, okay? And then as an extra added feature, right, I can change the way that it's displayed, and I can say that I want to, right, let's see. So I'm creating a plot, right, with my maximum temperature. I'm assigning that to this axis, or this AX. Then I'm essentially using the exact same command, right? I'm just changing my column. In this case, I'm looking at my minimum temperature, okay? The thing that links these two together is this ax equals ax, right? If I'm saying this, I want to use it, plot the data on the same axis, okay, essentially on the same figure, right? Remember, the figure is the canvas, and this axis is, right, individual plots that I can link to. And then, so if I were not to do that, it would, I think, let's see. I'm not sure. We'd have to try and run it, right, without having run it before and see if that changes it. So that's where right, I get a lot of help from Jupyter, but I also have to understand, I think by default, ax is going to be, right, the most recent one is already defined in the notebook. And so we would have to, right, restart and see. And then the question is, right, if I were to eliminate that code and run it as a pure Python script, right, I think it would give you 2 plots, but here, because axis is defined and already in the notebook, then it's giving me a same plot still, okay? But here, what we're looking at, right, I already have my index, right, corrected, and now I'm, right, very easily able to plot, right, these 2 values and display it right in my notebook. This means I can share it with my collaborators right, with these 3 lines of code. Okay. Okay, so we are just about wrapping up here. When I'm doing work in data frames, very often I find just printing out or saving a copy of that data frame is hugely helpful for debugging purposes. Okay? Luckily, pandas allows you right, to save data to _CSV, right? So I can export my data very easily with a single command. Okay? And then here, right, we can save it, right? I'm saving it in the current folder, right? And then I can, right, I can import that, right, and continue to work with it. But I would say, in large part, this helps me, right? If I double click on the CSV, it opens in Excel, and I can see, right, if what I'm thinking is happening, right, is in fact happening. Okay. If instead, right, this is very similar to the way the read CSV works. If I want it tab separated instead, right, then I would say that I want the separator to be this, right, \T, that's the tab character, and then it would export, right, the data as tab. Okay? But I suspect that, right, a lot of your data is going to be in Excel. Okay? So you can, right, go into Excel. You can export your data as CSV, then go into your Python script and open it. But because I would say it is so ubiquitous, right, pandas capability is built in, right, I can see that instead of using, right, my read CSV function, right, I have a read Excel function built within pandas. And so this allows me to, right, as you would expect, what is that first parameter for read Excel or read CSV? It's my file name, okay? Does anybody happen to remember, is that an optional argument or a positional argument? Right? It's a positional argument, which in some sense is an academic, right, point. But what's important is that, right, if I were to change these 2 values, right, so let's say this 0 here, which I'll explain in a minute, if I were to put that first, right, it's going to give me an error, right, because it can't find it, right? So that first positional argument, right, it's expecting the file name. And then with regards to the Excel reading is very, very functional and very capable, okay? How many worksheets are created in an Excel spreadsheet by default? And what is the name of that default worksheet? I would say for the most part, that's a detail that most people never, ever, ever need to know, right? I just opened Excel. I just worked in my Excel file, okay? So Excel opens up. It opens up with a single worksheet, but I have the option, right, of creating as many worksheets behind that as I want, okay? So when you open up an Excel spreadsheet, it's different, right, than opening up a CSV file. Right? The CSV file, there's one copy of the data, and that's it. There are no multiple sheets. So in order to work with the Excel data, we have to give it, right, more information, okay? Perhaps, right, if I want the data from that first sheet, then all I have to do is similar to the read CSV, is I give it the file name, and I can go, right? That means it's going to assume that you want that first sheet, and then it's going to ignore, right, everything else behind that, okay? So that is actually, let's see here. So in this particular case, right, if I want to use all the default values, then all I have to do is give it my file name, and I'm reading that first sheet, okay? However, I have the capability to read, right, specific sheets if I'm interested. And so in order to do that, I can either, right, give the sheet name, right? And so this is really helpful if your boss is sending you, right, your PI is sending you a particular report that he or she puts together, and you know that you always want to grab the data from the second sheet. But you also know that that sheet is labeled something, right, specific, okay? I can either refer to, right, the sheet by name, Okay, or I can refer to the sheet by index, right? And Python is a what-based language? Right, a zero-based language. So the same thing with these indexes here. It's going to assume that that first sheet is index 0, okay, and then index 1, index 2, and so on. And so here, if I want to read, right, this data file that I have, I'm saying I want to read the first sheet, the index 0. I'm going to, right, designate that there is no index column, right? That actually is redundant. I don't need to do that, okay? But for demonstration purposes, the reason I'm putting it in here is that if you want to designate an index, right, I can do that. And then what is nice is that if I want, right, my non-applicable or my null values to have a particular value in my data frame, I can designate that here with this NA_value. Okay, so if I want it to be the empty string, right, I give it the 2 characters, and then everywhere there is no value, right, it will import that as an empty string in my data frame. Okay, but this is, right, great functionality, right? I can very quickly open up my Excel files, right? I don't have to do any manual export of them. And then I can, right, I have my data frame and I can continue working, okay? And then at the bottom here, I think this is just some information on, say, location, right? And so I would invite you to take a look at that. We have, right, only scratched the surface, okay? I would say in large part, right, Pandas gives us great capability. I think in large part that capability is to get my data in a usable form, okay? Very often, right, I don't know about your lab, but I would say very often I encounter cases where data is not clean, right? And so getting it into a usable format is one of the real strengths of Pandas. And then, right, we see that there are, right, some limited statistical capability within Pandas, but there is another package called stats model. And let's go back to, right, this diagram here. And so we have been working with, right, NumPy. We saw that how Pandas, right, builds upon NumPy. But then if you are looking for, right, you've gone in, you've cleaned your data, then I would say if you're looking to do some robust statistical analysis, right, that is where something like stats model, right, then comes in. The reason it is a layer above is because it will, right, feed and understand, say, Pandas data frames and allow you to do statistical analysis, right, on Pandas data frames, okay? And so the advantage of the Pandas data frames, you'll notice that we never used, right, that keyword open to get a file, did we? Right? So it is entirely possible, right, for most of your Python programming life, right, to never use the word open to open a file if you're using something like Pandas or say NumPy, right, that you're using their file opening capabilities. If you're looking for more information, down here on the bottom, there are some links to some other resources. Wes McKinney, the gentleman who created Pandas and leads the team in developing it, has written a good book if you're interested. I think that's, I don't think that's a free book. I think it's a, what is it? Let's see, so I think it's Python for Data Analysis. I'm not sure this is the same thing, but in each of these different notebooks, there's other information on doing some compute, right, merging different data frames, right, doing other forms of selection of your data, and then doing information on, say, sorting your data. Okay. Any questions before we finish? Okay, as always, if you have other recommendations, right, or criticisms or critiques, I'd love to hear them. And I'm here for questions. Please make sure that you have, right, signed in on the sheet if you are here and have not. And other than that, I think we're taking about a week and a half break or 2-week break because of Thanksgiving. And then our next, let's go and find out when the next event is. So if I look at upcoming events, the 13th. So then I will see you on the 29th for data visualization. Okay. Thank you very much.
Just a suggestion. If you are saying you need, and this is very important, if you could also highlight things that you believe you cannot do in data or in this would be also a nice feature to add to what we're giving.
Yeah.
At some point, I mean, that doesn't have to be immediately. I certainly can say this is very, I mean, without it you cannot reach. But I think that the value, I mean, I can do it.
Right.
Why bother coming to
Right. Right. Thank you. Thanks, sir.
Can I have the URL for getting the your Python Jupyter notebook?
Sure. So that's just the GitHub and
Here, I'm on that. My wife wanted to make it, but she had to do some stuff with the kids.
well, I'm insulted you didn't bring the children. I know that my 9 and 7 and nearly 2-year-olds would love this stuff.
So we're going to sat here quietly.
So it's just let's see. I don't know that we can necessarily make that any bigger. I can make parts of it bigger, but not the URL. So it's just github.com. And then /Burke Squires, Squires. And then if you go there, that's fine. But then you can also go to Python_biologist. But if you look at, I think if you look at the homepage, then it's just the pinned repository up here.
Yeah, I've got it. I've downloaded it before, so that should be fun.
Cool.
Okay, thank you.
Sure.
You have 3 kids?
Yes. They're wonderful.
Boy, great.
Two girls. The oldest are 2 girls, and then a little boy.
They have 3 girls.
Do you? It is. They are. It's total joy.
Yeah, I agree.
Oh, I call it glorious exhaustion. Just so, but a lot of fun. And yeah, the little boy in the mix is just yes. So there is something to be said for genetics. And you know, despite the fact that there are lots and lots and lots of dolls, or seems like lots of dolls around, anything that makes noise, you know, it's like I'll touch the doll for like a second, but where's the things that make noise?
Yeah. Well, we find actually all 3 are very different, and our little one is also very fun.
Oh yes. So what ages are they? Are yours? What ages?
Oh, 5, 8, and 12.
Very cool.
And you?
What is it? 9, 7, and 2. So, yeah. The 9-year-old thinks she's teen at times. She's like the 9-year-old is prematurely preteen.
Yeah. Well, our 12-year-old is,
Oh, good.
Okay.
Thank you.